All right, hi guys, welcome to our meeting today, which is going to be a rundown of problem set 5 for chapter 7, which is the introduction to monopolies. And for the duration of the meeting, I'll mostly be just doing it on this paper, but also try to show you guys the question first. So yeah, we'll be beginning with the first set of questions on page 1, which is from question 1, 2, 3, 4 to 5. But when I'm doing the questions, unfortunately, it would be too difficult for me to share here and there. So I will just be going back to here on the slide, on the sheet. And yeah, well, let's begin. Okay, so admittedly, this homework set is actually pretty difficult. It's probably one of your hardest homework sets yet. So it might be going to be even harder for future chapters. So stay tuned for that. But knowing that, it's important to get the basics here into your brain, right? Because a lot of what you might be doing later comes from what you're doing here. And I want to begin with the very basic rule that in a monopoly, or at least specifically a single price monopoly, the rule is MR equals MC. Okay, so do know that. Likewise, remember, in a perfectly competitive market, instead of using MR equals to MC, we might use P equals MC. Okay, and also it's good to know, at least just right now, the differences between the various types of monopolies, first, second, third degree, as well as peak load pricing, two-part tariffs, intertemporal, stuff like that. But that's for later questions. For now, we could just go to the first question. So here it says that a monopolist sells product with the cost 1200 plus 0.5 Q squared, and our P is 300 minus Q. Okay, so we do know this, but how should we proceed? All right, so when in doubt, and you see this monopoly, it's always good to remember your formula, MR equals to MC, and see what are some ways we could make it into a such. Okay, so I think by now you might have realized that we could just do the derivative of cost, which will give you MC equal to Q, right? But how do we find MR is another question. And that brings us back to what MR is made out of. MR, right, is also going to be the derivative of revenue. That gives you MR. So to find MR, it's easier just to find revenue first and take the derivative of it. Okay, so how would we get revenue? What's the formula for revenue, guys?
P times Q.
Yeah, revenue is P times Q. So we could actually just use this. 300 minus Q times Q. Okay, now here is something I want to tell you guys. First, this question is nice because it gave you a demand curve that is written in the form of P equal to something of Q. Okay, and the P is just a coefficient of 1. That's good because you ideally want to use that. And specifically, remember, when you're graphing, you want to use P equals to something, let's say 300 minus Q. That's better than using the opposite of that, Q equals to 300 minus P, something like that to graph. Because when you graph, you begin from the y-intercept. And you want to know that the y-intercept through P equals to 300 minus Q. P is on this side, Q is on this side. The y-intercept is it. When Q is equal to 0, right, P will obviously be equal to 300 minus 0, which is 300. So that's your y-intercept. Now, you are able to get this point technically as well. You know, the x-intercept, Q equals to 300 minus P, that tells you your x-intercept. But thing is, we never really need to use that, the x-intercept at all. But the y-intercept, we use it all the time, whether to find some like consumer surplus, debt we lost, stuff like that. Okay, so the question is nice because it gave you P equals to something in Q. That is also the right format, right? When you graph, you want to use P equals something of Q. Likewise here, you also want to use P times Q where it's P times Q, and it's all expressed in Q's. And I'll go on later to tell you why it has to be expressed in Q's and not the opposite, okay? So here we get revenue is going to equal to 300 Q minus Q squared. So marginal revenue is going to be equal to the derivative of that, which is going to be 300 minus 2Q. Okay, so now you get marginal revenue. All right. Now, let me go on now to tell you why you can't use and express this in terms of P. So if we are to express in terms of P, we could use Q equals to 300 minus P. Revenue equals to P times Q, so that's going to be 300 minus P, 300P minus P squared. MR supposedly would then be 300 minus 2P. But why can't we use that? Well, because you want to pair MR equal to MC, right? MC is given to you as equal to Q. Okay, MC equals to Q. So you want to express your MR in Q and not in P. If you want to express it in P, well, you don't know what's the relationship between P and Q. You can't do it. So you have to express it all in Q. That is why you want to keep this in Q as well. So don't do that. Okay, so MC, which is Q, equals to MR, which is 300 minus 2Q. If we do that, we move the Q, we move the negative 2Q, that's at 3Q equals to 300, Q equals to 100. Okay, so we do now get the quantity at which our monopoly is producing. But one step before that actually allows us to answer question 1. Question 1 is asking for the range of output when firm revenue increases, right? So what's the range? Well, it comes down to using MR, right? Because what's MR? Well, MR marginal revenue means additional revenue generated from additional good. Good. So knowing that, we can say, let's say our MR looks like this, okay? Whenever our MR is positive, right, that means for an additional good we produce, that's bringing us more profit. Yeah, it is decreasing, right? This is decreasing marginal revenue, but it still means as long as MR is positive, as long as we have another good, it's going to build our revenue up. However, the moment it hits 0, this becomes false because then your marginal revenue turns negative. So all you need to do here is you find, okay, 300 minus 2Q, right? Where will it turn to 0? Well, it's going to be equal to 0, but we can just express it this. When is it greater than 0? Well, it's going to be greater than 0 when 300 is greater than 2Q, or when Q is greater. Sorry, no, when will it be less than 0? When will it be less than 0? So it will be less than 0 when Q is 150, right? So the range here is going to be 0 to 150. So that is how you would get this. Right, now, maybe I have overcomplicated things with this inequality mark. So let's just go back to basics and use it as an equal sign. Okay, just don't bother with the inequality. So if you use the equal sign, you find that when Q is 150, right, it touches 0. Okay, and that's good because all we need to do is know now, right, when it's not 0 yet, basically this part, or when it is from 0 to 150, we will have an increasing revenue. So that's the answer to question 1. All right, and for coming back here, so let me draw you actually the entirety of this monopoly graph. So we have in this monopoly, right, a demand of 300 minus Q, so that's your demand. We also have a marginal revenue of 300 minus 2Q. So let me ask you this. Will the marginal revenue be to the right or to the left with a steeper slope, if you have a steeper slope, right, a larger slope, it's actually going to be to the left of it. So this is how it would look like. So that is your marginal revenue, right? And this point is 300, right? This point is 150. This point is 300 because that's the y-intercept for both 300 and 300. Okay, so if we have that, we have the basics. We also have an MC line. Okay, our MC line is equal to Q, right? So let's say the MC line is MC. Now the question is, where are we going to produce, right? So we produce when MR equals to MC, right? We already solved for that. We get Q, which is here, equal to 100. But we get MR equals to MC. That's the first step because we do get the quantity, but we don't get the price yet. The price is actually not this point, okay? The price would instead be this point, which is where the price is 200. How do I know when the price is 200? Well, so here you see you get the quantity of 100, and you apply this into your demand curve, right? So your demand is equal to 300 minus Q, which is 100. That gives you 200. That is going to be a price, and that would be a price in a monopoly. So that's your answer to question 2. But I'm sure some of you might be wondering, well, why is 200 the price and not 100? Well, I mean, it's just basic idea. This is a monopoly, right? You want to maximize money. You're not thinking of doing a social good here. You're trying to earn as much as you can. And in a monopoly, you see, you have market power as the monopolist. You have a say in deciding the price. So in a PCM, that would be this point, okay? Typical where you could say P equals MC or demand curve equals to MC. That is going to be typical, right? And your quantity is 150. Your price is also 150. But now that you have a say, you can choose to charge the price higher, and it's going to be fine. And why do you charge it to 200? Well, that's because it has to be according to the demand curve. Let me ask you, what does the demand curve mean? What's the point of the demand curve? The demand curve, it signifies, consumers' willingness to pay. Given this quantity, quantity of 100, they'd be willing to pay 200 because, you see, compared to your equilibrium, which is 150, 150, now you have less quantity. It's more scarce. So they want to pay more for this less quantity. And therefore, the price goes up to 200. You use the equation of the demand curve to get that. Okay. Now, question 3. Okay, so question 3, we go back to finding profit. Now, profit, I mean, there's a lot of formulas we can use, but here, it comes down between 2, right? Either revenue minus cost, or the other one, like P minus ATC times Q. And you take a look, okay, whichever one is more suitable for you. It's going to be the first one, because it gives you a cost function already. All you need to do is find the revenue and plug in the Q into the cost. If you want to find P minus ATC times Q, okay, but you need to simplify ATC. And what's the point? So revenue minus cost, that's going to be what? Well, revenue is P times Q, right? So okay, P times Q. And minus the cost, which is 1200 plus 0.5 Q squared. Okay, we could express this as small q. So now we go back, we plug in the numbers. 200 is our price, right? Quantity is 100 minus 1200 minus 0.5, 100 squared, which would be 10,000. So that's 20,000 minus 1200 minus 5,000. So that's 13,800. Okay, now I just want to make a note here. It's quite an interesting thing, okay? But in a monopoly, you can express small q, big Q. It's technically both fine, right? Although in the question it uses big Q, but that also makes sense. Why? But because in a monopolist market, there is only one seller, right? There's only one person selling. So what this what this monopolist is, he or she is basically just the market. He controls the prices, he dictates the quantity, which then controls the prices. So in a monopoly, you see, the monopolist sets it all. They make the prices. They determine what this industry looks like, what this market is about. Whereas in a perfectly competitive market, you have a bunch of little sellers who have no market power, so add together they make up the market. In a monopoly, you have the monopolist doing everything. So you can express it both as P, a large P and large Q, which means market normally. You could also express it as small p and small q, which normally means firm, but both make sense. Right. So the answer here is 13,800. And for question 4, okay. Well, it asks if the market is perfectly competitive, how much you produce. By this graph, we already got 150, but you might be wondering how I did it. Well, it's just using, let's take a look, right? This intersection is between MC and D. So it's just using your D equals to MC. What is your D? Well, it's given to you very early on, it's 300 minus Q. What is your MC equals to Q? So you manipulate it, 2Q equals to 300, Q equals to 150. There you got the price, right? And also the quantity. Sorry, there you got the quantity, and you also get the price, because remember, price is just equal to 300 minus Q, 300 minus 150 is 1. Yeah. So that's that. And the last part is to calculate the deadweight loss. Now, actually, let me say something here. That is that previously this answer was wrong. Previously, the answer key, this was 1250. And some people, they came to my PAL session, or they asked me on email and I told them it's 1250, and I even gave you guys a sort of wrong formula. This formula, you can find it online, but somehow it's not really correct. The correct answer is not 1250, right? So I apologize to that if anybody did the question with me earlier. And this also proves a point about me, okay, me as a person. I take, when I'm doing these questions, I can get most of them correct, but sometimes I'll get it wrong. And when I get it wrong, I go back to the answer key. The answer key tells me something, and I'll use the inductive reasoning, I guess, to basically reaffirm me. I find things online, I search it up, or I ask AI, something like that. Why is it this answer? And it tells me a reason, and I accept it, except the reason might be wrong, or in fact, the answer key might be wrong. So, here, right, we just stick to the normal way of doing a deadweight loss, right? Deadweight loss, how do we do it? If we draw this thing again, okay, MR, D, MC. Deadweight loss is going to be here. This point is 200. This point is 100. The midpoint is 150. This quantity is 100, and this quantity is 150, right? We all derived this here. Oh, by the way, you might ask, why is this 100? And if you if you don't know, how can you calculate it? Well, you could use the MR line. You could also use the MC line. As long as you got the quantity, right, which you did by using early on MR equals to MC, right? Somewhere here you got the quantity being 100. You plug in this quantity into the MC line. MC equals to Q, right? So Q is 100, and you say, oh well, this point then must be 100 as well. Or you could use, even better, the marginal revenue line. Where MR is 300 minus 2Q, right? 300 minus 2 times 100, 100. Both of those tell you that this is 100. Okay, so now that we lost, to do it, by the way, I changed the answer key. So if you select the correct answer now, you'll get the right answer, okay? 1/2, right? 200 minus 150. Sorry, that's the wrong answer. 200 minus 100, right? And that's basically your height times your base, I suppose, which is 150 to 100. That's going to be 1/2 100 times 50, so 2,500. Okay, that's the right answer, and that's the right answer that most of you guys sought, right? Most of you guys thought that's the right answer, and it is except it was initially marked wrong, and I even gave wrong explanations to do one. But another way, by the way, it's always good to draw out and calculate the triangle area. That's the correct way to do it. But if you want a formula, you could also derive it here, I guess. So you see the formula, okay, for debit loss in a monopoly is going to be the difference between your price minus your marginal cost, okay? P minus MC, at the start it's 1/2, okay? Because it's a triangle. So P minus MC times your original equilibrium, okay? In other words, your quantity when it was a perfectly competitive market, minus your quantity now, okay? Quantity at a monopoly. So yeah, I mean, you could also know this formula, but it's not mandatory, and in the end, it's actually not even that helpful. As long as you have the triangle drawn out, you'll get it, okay? So we get the answer now. Now let's go to page 2. This thing takes a bit longer time than expected. All right, but this question on the plus side is relatively easier, I suppose. So now it's asking us about the learner index. So this is just definition. Learner index is what again? Well, the formula, right, is P minus MC over P. So your learner index equal to P minus MC over P, which also equals to 1 over elasticity. Okay, and normally we put it as because this is going to be positive, so you also want the elasticity to be absolute value or positive. So yeah, it's not that big of a deal. So here, just by knowing this, you might not be able to answer it, okay, because you don't really know what to compare with. But it also gave you that elasticity, right? It gave you that price is 20, but you see, marginal revenue is 20. Okay, I mean, that you might not know what price it is, and you might not know what marginal cost is, just telling you that, right? And also give you elasticity is negative 2.0. Okay, so it's pretty elastic, right? Now, first things first. In a monopoly, what's the golden rule? What's the formula? MR equals to MC, right? And to draw a quick diagram, MR, V, MC, right? This point, MR equals MC, you're going to use it to determine your quantity. It matters a lot because you're also going to use the quantity to determine your price. So knowing that MR equals MC, we could just write it as MC equals to 20. Okay, MC equals to 20. So now we got MC mastered. But we don't really know what's P, right? So that's the thing we're trying to calculate. P minus 20 over P equals to 1 over E. And luckily, you see, we have E being provided. E is negative 2.0, so we put the absolute value, that's going to be negative 1 over 2, right? So now you know 1 over 2 is equal to P minus 20 over P. If you're sort of intuitive, you might as well have already realized that this is a half. So that means that this number needs to be half of this. So basically P is going to be 20 times 2, so P is 40. But even if you don't, it's always not wrong to cross multiply. Okay, so cross multiply 2P minus the 20. Let me do it like this. Equals to P. So 2P minus 40 equals to P. P equals to 40, right? Switch side, this goes that, this side that. So P equals to 40, you got it nonetheless, and that's that. Now, also the question 6, which asks for the learner index, well, you could just use this, right? You don't even need to derive P yet. You just know 1 over, absolute value of 2.0, that's 1 over 2. You get learner index is 0.5. The firm's price is 40. And lastly, question 8, in a perfectly competitive market, what is your learner index? Well, think about it. In your perfectly competitive market, what is it? P minus MC over P, right? And what's the golden rule in a PCM? P equals MC, right? So you see, that's another reason why it's really important to know MR equals MC for monopolies and P equals MC for perfectly competitive, so that you know their difference. And when you apply the learner index, it makes sense. So P equals MC, Therefore, if we assume that all of them are equal to a random number 3, okay? 3 minus 3 over 3, that's 0 over 3. Your PCM learner index is always going to be 0, right? Yeah, now you might say, okay, well, in what time would the learner index be 1? Well, learner index would be 1 when, right, P minus MC over P is equal to 1. And your MC is equal to 0, right? But let's say if this is 20 and this is 20. This is 0, 20 minus 0. So physically, that's not really going to be very possible, right? It's only going to be very, very rare cases. And most times we're going to get a learner index. It's typically going to be a good number between 0 and 0.9 because it's not 1. So yeah, that's 6, 7, 8. Any questions here? Yeah.
Wait, I just wanted to clarify the answer to question 6.
Uh-huh.
Is it 2, right?
Why is it 2? No, it's not. Sorry, but it's, you see, P minus MC. Or no, we could more directly use 1 over E, right? Learner index, if you're, did she teach you guys this? It's 1 over elasticity.
Should have went over it quickly.
Yeah, okay, no problem. But yeah, learner index is 1 over elasticity, 1 over 2, so 0.5. Yeah. Now, also, it will never be greater than 1.
Okay.
Yeah, so the 2 you can automatically erase. Why? Well, I mean, that's pretty much saying that P minus MC over P, if it's greater than 1, that's saying that MC is going to be negative. Meaning for additional good you produce, the cost is negative. That's like, how is that physically possible, right? So it's pretty much never going to happen, right? So it's going to almost always be between 0. Although, I suppose you might say if it's an inelastic scenario, it might be. If it's inelastic, it might be. But it's weird, okay? Don't see them asking that much about inelastic. Okay, question 9. So these questions are sort of similar to just understanding the basics of Monopoly. And really, it's nothing too difficult. So here they are, 9, 10, 11, 12. Let's just put them on paper. Okay, so first, it's asking about what a monopoly is, whether marginal revenue is located above or below demand. I mean, you probably do remember this already, but MR is always going to be the one closer to your y-axis, and D is always going to be one further from the y-axis, okay? So in that sense, you would say the marginal revenue is located below demand, okay? Now, here's a heads up for all of you guys, and listen carefully. Quite important. In pretty much all the problems you're going to see, your MR, like let's just use the first question that we did, right? Remember, MR slope 300 minus 2Q. D slope 300 minus Q, okay? In pretty much every scenario, these things, first, they would have the same y-intercept. Okay, that's for sure. They'll all begin at 300. But MR would have a slope 2 times of D, almost always. Okay, so that's why that means that MR is twice as steep as D. So, at this point would be 150 where it crosses 0, and this point would be 300 where it crosses 0. The difference from here to here, right, if we call that A, well, the difference from here to here would be 2A. Okay? But why is that? It comes back to what marginal revenue is made of. Remember, this your demand curve, right? It's basically P equals to 300 minus Q, right? That's your demand. So when we are going to find MR, right, we're going to do the derivative of revenue. Revenue is equal to 300 minus Q times Q, which is 300Q minus Q squared. Now, if we take the derivative of revenue, dx, then sure, this part you don't care because it's derivative, that's 300, and that also explains why y-intercepts are the same, okay? Because if you take derivative of this with an exponent of 1, it's not going to cause it to change. But here, it will. Because if you take a derivative of the exponent of 2, right, instead of it being q squared, it's going to become 2q. And this 2q, right, or double the slope of our original price. It is exactly what it is. Okay, so that is why almost always you'll see that your MR slope is going to be 2 times that of the slope of your demand curve, which in other words just means that it's going to be 2 times steeper, or the distance from here to here is half the distance from here to here. Okay, almost always. Now, you see, it's because you use q squared. If for some reason you have a price curve that looks like 300 minus q squared, then that's not going to be the same. If it's like that, then it's going to be 3 times. But in almost all of the questions you do here, the q is, at least the demand curve's q, has an exponent of 1. So, in the end, you're going to see a marginal revenue of the slope 2 times that of the demand. Okay, question 10. Computer competitive market, monopoly sells in the quantity. Well, we could just use this graph, okay? Compared to a competitive market, right? Competitive market is what? Your perfectly competitive place, right? PCM. So you see, you use MR equals to MC. MR is this line. MR combine MC, you get intersection here that gives you whatever quantity. That quantity, however, is clearly lower than your PCMs, right? And it is precisely because your quantity is lower that creates scarcity, which allows you to impose the good at a higher price according to the demand curve. So it's not a one-step process of saying, oh, monopolies are price makers. They just make the price. Instead, they decide on the quantity supply, okay, which is MR equals MC. That gives them quantity. They use this quantity to then determine their price. Okay, they use the quantity to establish the adequate price based on the demand curve that they would set to customers. So quantity lower, price is going to be higher, right? Higher than your original PCM, it's higher. Why? Well, because there's scarcity. There's less goods supplied, so customers are willing to pay extra just to get this. So the answer here, a monopolist, compared to competitive market, monopolist sells a lower quantity at a higher price. All right, question 11. All right, this is not a bad question at all, and it comes back to the first part of your, let's just say the part leading up to your first exam, right? You guys learn about the total revenue test, right? So total revenue test, what it says is, you know, if it's elastic, you want to what? Raise price. No, you want to decrease price, increase quantity. If it's inelastic, you want to raise price, decrease quantity. But you see, most of you guys are not going to memorize that, and that's totally fine. I don't even encourage you to memorize that. It's really stupid. And it's almost self-explanatory if you realize it. So here, let's say elasticity demand is negative 0.15. So let me ask you, elastic or inelastic? Anyone? Elastic? Yeah, it's inelastic. Okay. Again, why do you know it's inelastic? Well, because elasticity is less than 1. Right? That makes it inelastic. If it's equal to 1 unit, if it's greater than 1, elastic. Okay, but here it's less. 0.15 is less. So, in an inelastic scenario, what's going to happen? Let's apply that on a graph. Okay, that's the best way to do questions like this, because by drawing it out, you know pretty much what's going to happen. So, you have a very inelastic demand curve. It's still sloped down, you see, but it's just very much close to a vertical line. And what would you want to do here to maximize profits or earn more money? Well, let's think about it like this. Okay, on this curve, you could either choose to, it's asking about, you know, increasing output, decreasing output. Let's first think about it in terms of price. Okay, if you increase price, okay, let's say if this number here is 10 and this number here is 30. Okay, if you increase price from 10 to 30, well, that's a 200% increase. Okay, these are hypothetical numbers, but they're not that strong, so very. But what about quantity? The quantity, let's say it's 10, and here it would be 7. Okay, so that's a 30% decrease in quantity compared to a 200% decrease in price, a 200% increase in price. So if you're going to do something like this, is it helpful for your final revenue? Well, it is, okay, because your original revenue, let's say it's 10 and 10, right? 10 times 10, not bad, 100. But your new revenue, you use these new numbers, 30 times 7. That's going to give you 210, right? So that's more. A better revenue. So by now, you already know that you want to increase price and therefore also decrease quantity in a inelastic scenario. Okay. By the way, because I chose these numbers, this would also give you the elasticity here would also actually be exactly 0.15. But you don't even need it to be like that. You could put this number as 5 or put this number as 8. But as long as it seems like inelastic and it sort of makes sense to the graph, okay, then it's going to be fine. Right? And also, do remember that inelastic looks like this, and elastic would look like that, right? Knowing that, you just plug in some fake numbers almost, and you see, oh, previously my revenue is so and so, my new revenue will be so and so. So yeah, the better choice here would be to decrease output. Okay. In comparison, for an elastic, that's going to be, you want to decrease price a bit so that causes a great increase in output or revenue, a great increase in quantity or output, which gives you more revenue. Okay, so elastic, P drop, Q plus, inelastic, this is good. Inelastic, P plus, Q drop. But because P, you see, in an inelastic single scenarios like this, P grows so much more than Q drops. So that's also going to be good. Now, another way to remember what inelastic good is to think about it as a necessity good. I know you guys haven't really heard of that term in economic sense, but you have heard of it in a common day vernacular sense, right? Necessity, something you need, like let's say eggs, and indeed the prices of eggs have been increasing. If the price of an egg increases from, let's say, 50 cents to 150 cents or $1.50, right? Good. But will the demand for eggs fall that greatly? Not really, because it's a necessity good. So that would make it an inelastic, right? So inelastic, you can also think of it as necessity. And yeah, so that's it. Lastly, question 12. Okay, so whenever you come to something like this and you don't know what the hell monopsonist is, just search it up. Okay, that's your best bet. But even if you, after you search it up, you don't understand, then sure, you can come to TA session. So what a monopsonist is, okay, is that it's the opposite of a monopoly. A monopsony is opposite of monopoly. In a monopoly, right, you have what? One seller, right? One seller who is basically the entire market. In a monopsony, you have one buyer, okay, who also represents the entire market, but from a different degree. So here, the monopsonist also has full market power because he is the only buyer. He can dictate a lot of things. Right. Now, normally, monopsonies ties into something like the labor market. So let's just use that here. It's also fairly easy to understand. Remember, in a labor market, your demand is going to be the demand coming from firms, right? And you have a supply of workers, which is just, given your price increase, more people will want to work. So you have a demand and supply. But what makes a monopsony a bit different now is that you also have something called an MV, or marginal value, the additional value generated from additional work. Okay? So in a monopsony, let's actually go back to monopolies first, just for you guys to get a recap, right? In a monopoly,
This is your MR. This is your MD. Yes, bad drawing with Soviet. This is your MC, right? You originally your PCM is gonna be here, and your PCM, right, is gonna be where your MC, or in other words, remember, supply is marginal cost, right? So they're the same thing. Marginal cost or supply intersect with demand. So yeah, that's our PCM. Likewise, here is going to be our PCM. However, in a monopoly, we don't choose our PCM. Instead, we use MR equals MC. At this point, we get the quantity and we raise the price. So similarly, in a monopsony, we also aren't going to use demand equals supply, okay? Or price equals supply or something like that. No, P equals MC. No. We're going to use MV equals to, we're going to use MV equals to demand. Okay, right? MV equals to the price. But if you see, we're actually not going to just use here. So it's not just MV equals to price. We do use MV equal to the demand curve. Okay, we get that quantity. Likewise, in a monopoly, we also get the quantity first. But we don't set the price there. No, we set the price here. So that's what makes it different. In a monopsony, you actually have a lower price than your market. Whereas in a monopoly, you have a higher price. And this makes sense because remember, a monopsony is one single buyer. As a buyer, you obviously don't want to pay that much money, right? And likewise, because we're doing a labor market here, so supply is going to be supply of workers. Demand is demand of workers by the firm. The single firm, let's say this is a mining town in West Virginia, right? Where else would it be? And there's only this one corporation, big ass mining mine there, okay? And that's it. They can dictate all the prices. But are they going to want to hire you at that much of a wage? No. Because they have full market power, they want the wage to go lower. And indeed it will. It will go to the wage according to the supply. Okay? So why would it be here, right? Now, if we come back to monopoly, remember that we set the quantity, right? We all get the quantity here. The quantity here as well. But we link it to demand. But in a monopoly, we link it to demand because we want to see, given this quantity, how much will consumers be willing to pay for this good? Here, it's sort of the same, but in the reverse logic. It's also going to be given this quantity, okay? But it's going to be given this quantity. What is the least amount I can pay such that this amount of workers will be willing to work for us? Supply is the supply of workers, right? So you have this this set number of workers you want to hire, let's say it's 8 workers, okay, and you aren't going to pay them that much. You just want 8 workers, and you're going to use your supply curve in a way such that it gives you 8 workers and only 8 workers. To get 8 workers interested in your job, you need a pretty low wage than 16 or 20 workers. You need a much higher wage that attracts more people to come, right? But just for 8 workers, not a lot. You don't want to put that much wage up there because it's not necessary. There's going to be impoverished people who are really poor in this mining town in West Virginia, and they're willing to take this pretty bad job and inhale all the smoke because they have nothing else, and they're willing to take it. So that's why if you just set a lower price, you have 8 people willing to come. And that's all you need. So that is what it is in a monopsony. You buy a lower quantity at a lower price. Okay? So you see, both monopoly and monopsony have lower quantity, but price is different. In a monopsony, it's about the buyer. You don't want to pay that much. Right? You want to maximize your own surplus by paying as little as possible, so you have a lower price. In a monopoly, you're the seller. You want to maximize the profit. You want to set as high as possible. So that's going to be a high price. Okay, we somehow, after like 40 minutes, only got through half of these questions. So, okay, luckily 13 to 18 are, 13 to 17 is pretty quick. So let's just get through it. Okay, first, firm charges. Oh, charges each consumer by reservation price. But what type of, guys, if we want to split it up, what type of this price discrimination is it?
First degree.
Yeah, first degree. And what is first degree? First degree is that you just maximize according to each customer, okay? It's not according to the traits or how much they buy. It very simply is just, given their own attributes. If you're rich, they charge you more. If you're poor, they charge you less. Something like that, okay? So just traits of individual customer. And in this case, you see it's called individual reservation price, but they're going to set a higher reservation price for rich couples, lower poor ones, so yeah, individuals. Okay, 14, 15 out per hour for children, 30 per hour for adults. Well, this is another type of price discrimination, right? Because instead of traits of individuals, now you're doing traits of like groups, and you specifically separated the groups, right? Children are softer, so you give them 15. Adults are firmer, so you give them 30. So what type is this? Yes, there's a third degree where you charge it according to the trait of a group, okay? And children, adults, very common. You see it in airlines, right? But airlines also have a lot more. So airlines are very, very, I shouldn't use the word, but they're not good. Okay, you see here, they'd be using a bit of this. They might also use peak load pricing. They might also use just maybe even intertemporal sometimes. So it's crap. Okay, yeah, and I mean they're indeed a lot of oligopolies, so they do have market. Okay, 15. Amazon Prime charges $12.99 a month. I don't know, is this number still accurate? I don't use Prime, so I actually can't see it. $12.99 a month plus goods, the cost of goods. So I mean, what is this? You have this basic $12.99 that you need to enter the market, right? To even get the service of Prime, 2-day delivery, something like that. And you also have to pay the good. So this is a two-part tariff, okay? And how do I know it's a two-part tariff? Well, there's two components. First is the part you need to enter the market, and it is the part you need to spend in the market, okay? So 16. A firm charges only 25 cents more for a large soda than a small soda. Well, this is going to be something about size, right? Or specifically quantity. So let's say 125 for big can, 1 for small. So this is this is by the quantity. That's just going to be second degree. It's sort of important to know first, second, and third. They might ask you a question about this, and frankly, this isn't something you should get wrong. Right? Just have an idea what it is, and yeah, because there's going to be so much harder questions, including the last two that we're going to tackle, that is just much harder. And like if you get something wrong, that understandable, and here it's not really worth it, right? So 17, well, it says okay, more for electricity at like peak hours, right? Which is shouldn't peak hours be at night? Well, I mean it depends. Like maybe for office buildings during the day. So more electricity bill in the peak or like during the day than night. And I mean, regardless of which one is our peak, supposedly the day is the peak, okay? But regardless of which one you choose, this is going to be peak load pricing because it's specifically choosing, peak load pricing because it's choosing a different time given different levels of demand of electricity during the day. And lastly, there's a question of what are intertemporal. So any idea of what intertemporal price discrimination is? So yeah, intertemporal price discrimination, I remember the example I learned from my professor last year is iPhones, okay? So intertemporal iPhones. Why iPhone? So initially they charged the price high because it's all hyped up. iPhone 17 is going to be released. They're going to make it up price pretty high. I don't know, around like $900, let's see, right? That's the first year, and they slowly start to decrease it because over the next year maybe it drops to $799, and next year like $699. The year after that it's going to be a bit lower, a bit lower, a bit lower. So that's going to be intertemporal. Intertemporal very much just means different prices at different points in time. And oftentimes it begins with high and later goes low, because originally it's attracting people with high willingness to pay, and later it goes down to lower willingness. Another one would be airlines. Although airlines is weird because, just based on personal experience, obviously the price is leading up, the price is going to be high. But it seems like if you book too early, the price is also going to be high. And if you book at a time, let's say 2 months before it, it depends. So it's sort of hard to say. In my experience, I feel like the price of airlines looks somewhat like this. Okay, like something like that, which is just weird. Whereas this might be like, let's say 12 months before. This might be like 6 months, 3 months, 2 months, 1 month, and a few days before. This might be how it looks like for airlines. And well, again, back to the point. So airlines are scammers. So yeah. All right. There we go. So now, all right, this question. Not very easy. Question 18. By the way, any questions? No? No? Okay. So question 18 to 22. It's asking, it's given a demand curve and a marginal cost. And it asks you to charge, okay, what happens if it will charge a single price? How much profit? And what happens if it can perfectly price discriminate? Okay. And lastly, how much would be willing they be willing to pay? Okay. So long story short, this is also going to be about using the same old formulas, whether that's MR equals MC or P equals MC. Any guesses on which one we are going to use MR equals MC? Well, yeah, we're going to use MR equals to MC for monopoly, but specifically what type of monopoly? A single price monopoly, okay? This thing would actually not apply in, this thing would actually not apply if it's, a different, like the different types that we just mentioned, first, second, third degree. It actually, no, even for like two-part tariff, we would actually want to use P equals MC. All right, and we would also use P equals MC for the other type here, which we said is perfect price discrimination. And ironically enough, okay, it has the name perfect in it, just like a perfectly competitive market. And you're going to use P equals MC, okay? Except in a perfectly competitive market, right? That's like doing good, right? You don't have any say in the market. You're just using the price that the market dictates, and you get consumer surplus really high. But here, in what we call perfect price discrimination, or in other words, a first degree monopoly, we actually suck it all of their consumer surplus. The consumer has no surplus, right? We'll get to that later, but let's come back to question 1819 because we still need it for, for this, whatchamacallit. We still need to do it first using MR equals MC. The latter part, by the way, I personally find question 20, especially 21, to be quite difficult. So yeah. All right, let's go. So MR equals MC. Again, if you remember at the start of this recording, right? When in doubt, you use this. And when you use this, you try to find each component. MC is gladly provided by Professor Kaplan. How generous of her. But MR is uncertain. Okay, now, the other TA, Letitia, has came. Letitia, feel free to help any of them if they raise hand or ask questions, okay? It's okay. The noise is not going to spread here. But this thing would still take at least 20 minutes. So yeah, help it. All right. MC is equal to 5 plus Q. What is MR though? Well, hard to say, right? But again, remember, MR is the derivative of revenue. So we can find revenue. And remember how to find revenue. Revenue is equal to P times Q. Good. So we could try it out. And indeed, we have Q equals to 130 minus 2P, right? How about we just time it by P? PQ is equal to 130P minus 2PQ. And, so and so, you get that's revenue. MR is equal to the derivative of that, which is 130 minus 4P. Very good, except if you want to combine MR equals MC, or 130 minus 4P equals to 5 plus Q, you'll get a what the heck answer. Because what is the relation between P and Q? We don't know. So, okay. And back to the basics. I know I stressed this out during the first question, but when you do this, you can't use Q equal to something P. You got to use P equal to something Q. So that's exactly what we're going to do. All right, we flip it. P, right, said is equal, no. Q is equal to 130 minus 2P. 2P equals to 130 minus Q. P is equal to 130 over 2, right? So 65 minus Q over 2. Now, there we go. So, now also, this, right, this one we get is a demand curve, okay? Just P equal to 65 minus Q over 2. That's the ideal way to express the demand curve instead of something like this. Okay, because if you have like this, you're going to graph it out easily using the y-intercept. But if you're just trying to solve trying to find the intersection of a line or like trying to combine, let's say this is your demand curve, right? You have a supply curve as well. You want to combine this, your demand curve with a supply curve, which technically is MC. You could just use it like directly as it is, as long as it permits. Okay, that's fine. But the reason why I don't want you to use it like that much is because most of the questions you see, you have to graph it. And if you have to graph it, it's just better to simplify into P equals some sort. Okay, and then you find P equals to 65 minus Q over 2, and then you graph it. It would also be easier for you. So now we have P. We are going to find revenue by using P times Q. So revenue is equal to 65 minus Q over 2 times Q, right? So that's 65Q minus Q squared over 2. So we take the derivative of that. ddx rev is equal to 65 minus Q, right? Why? Well, you see this is 0.5 Q squared. I take the derivative of that, that's 1. This to simplify, but 0.5 times 2, which equals to 1. And yeah, so that's your coefficient at Q. So 65 minus Q. And also, if in case you haven't realized, the slope here in the MR is 2 times the slope of demand, right? Well, yeah, because you see here the slope is half, or Q over 2. Here the slope is 1, right? Or, yeah, 1Q. So, now that we have this, we could try to merge them together, but I suggest you to draw a graph first. It might help, it might not. But, I mean, if you have 70 minutes on your exam and 20 questions, why don't you just draw it out? It's not going to hurt anything, really. So, okay, we have first 65 being our y-intercept here. And we also have, what is it? this being our demand curve, and the MC. Oh, now you see our MC is going to be a bit different because our MC also has a coefficient, and it begins with y-intercept of 5. So okay, it's actually going to look like this, MC. And in a single price, you're going to find this point where MR equals MC, and you're also going to find the point. Okay. So let's try it, right? MR equals MC. So 65 minus Q equals to 5 plus Q, right? So we move the Q to that side. QQ is equal to 65 minus 5, 60. Q is 30, not bad. And the question is, we're trying to find the price. So we found the Q. So how are we to find this price? Well, it's not really hard as well. Because all you need to do is plug it into the demand curve. And you got the demand curve. You could either use this P equals to 65 minus Q over 2, right? And that's going to give you a demand curve of, it's going to give you a price of P equals 65 minus 30 over 2, which is 15. So 50. Or you could also use this equation. 30 equals to 130 minus 2 pp is going to be 50. So yeah, you got the price. That's question 18. However, question 19 is going to be quite difficult. Okay? And it's not necessarily to say that it's not doable. It's just that you need to get the gist of what you're doing. So it asks for profit. Okay? Asks for profit. Now, what's the formula for profit? Revenue minus cost, right? Or P minus ATCs, parentheses, times Q. Here again, you don't have ATC. In fact, you don't even have a TC. So, what are we going to do? Well, let's stick with the basics. Revenue minus cost. Your revenue is P times Q, okay? P times Q, and cost. Well, cost is what? VC plus FC, right? Variable plus fixed. And it is stated in the second line of the question. Letitia, feel free to help.
Oh, yeah.
Okay. Also, guys, don't hesitate to raise your hands. I know.
Yeah, you guys just raise your hands and we'll
Yeah,
hear.
because I know you guys have more specific questions. This is just a homework, and yeah. But if it's like question 22, something that we haven't gotten to yet, but we'll get like a couple. Just wait for it. Yeah, Letitia.
Oh.
Okay. Anyways, so it's equal to VC, or variable cost plus fixed cost, right? And it's stated in the second line of the question that FC is 0. So okay, again, very generous as Professor Kaplan. We don't care about it. So all we need to do is PQ minus VC. But how do we get VC? And here is the killer, right? So to get VC, you have to somehow manipulate marginal cost. But how? Right. So let's come back to, let's put a completely hypothetical scenario, okay? Let's say you have a cost function equal to 300 plus Q squared, okay? That's your cost function. This is going to be your fixed cost, right? This is going to be your variable cost. Fixed cost, constant, variable cost depends on your quantity. Now, if we take the derivative of it, MC, which is the derivative of C, that's going to be, we don't care about this, 2Q, right? 2Q. Good. Now, we have MC, just like we have MC in this question. How are we to find variable cost?
Right?
Yes. Any ideas? Using MC to go back to find variable cost.
Exactly.
Yes.
This
What'd you say?
good equation is gonna have.
Yeah, you take the, well, I mean, I don't think,
And
it's called integral, yeah, not after the integral. But you take the integral, and if you take the integral of MC, right, which is just 2Q dQ, that's gonna be Q squared, very well. But if you realize this is just your variable cost, right? So the derivative, sorry, the integral of MC only gives you the variable cost, not the total cost, because we very simply just can't account for FC. So like sometimes the question might give you the FC, or sometimes you need to find it somewhere else. But the point is here, you're not going to find the FC. So that is why, when we normally do integrals, we're going to have a plus C constant, right? So like if we're just doing this, we might get it to Q squared plus C, where the C would technically refer to the fixed cost. But actually, we don't know it, we can't really derive it unless the question gives us this number or it gives us a way. And here, it just gave us 0 as a fixed cost. So you don't even need to care about it. All you need to do is find the variable cost. Now, variable cost, as we know, is the derivative of MC, which is the derivative of 5 plus Q,
Equation as well.
which is going to be
Because you get your
5Q plus 1/2 Q squared. Okay, now, careful here, right? Remember, it's always like, she's not going to make it hard for you really, but you just got to be careful. If you're taking the integral, right? So you could think about it, instead of taking the integral, I'm taking the derivative of this number to get to Q, right? It's going to be 1/2 Q squared, where the exponent cancels out the 1/2, and it's going to be Q, okay? So that's our variable cost. So very good, plug in numbers. 50 times 30 minus, what's Q again? Q is 30, right? Yeah. So 5, 30, and remember to consider this thing as an entirety, plus 1/2 30 squared. So 1,500, and you have calculators on the exam, okay, so it's no worries. Minus 150 plus, what's this? So 300, 30 squared is 900, right? 1/2 900 is 450. So there we go. 1,500 minus 600 gives you 900. Okay. Oh, by the way, guys, I know you can't see it. So if you can't see it, just tell me. Nobody cares if you interrupt. Okay. Remember, you're also doing dumb and good. Yeah, just tell me if you can't see it.
Yes.
When I'm doing the questions, I don't watch the screen. So here's question 18. The single price is going to be 50. Quantity 30, but it's not asked. And the profit made is 900. Okay. Go.
Like for profit, can you also just do the producer surplus minus the fixed cost and then find the producer surplus?
That's also correct.
Okay.
Yes. But I mean that's good to know. So somebody raised a very good thing to know. Okay, and which is actually, by the way, I'm going to tackle question 21. But the reason why I didn't want to share it now is because I feel like it'd be more representative there. But let me just tell you guys here. So you see, producer surplus. Yeah. It is also called variable profit. The specific reason why is a bit too complex, so we won't go into it. Well, variable profit means your revenue, or in other words, P times Q, minus variable cost. And if you get that, and you get the variable, and you get P times Q minus variable cost. And again, I mean, you still have to derive the variable cost somehow, or in other words, you can just find the producer surplus. Both of that will give you the same result. Okay, so here you see P times Q minus VC. Yes, that is the profit. That is also your producer surplus. However, if this question has a fixed cost into it, then you can't just say that producer surplus gives you your final profit. Okay, if it has a fixed cost, if fixed cost exists, okay, then I mean to get the profit, you're gonna do PQ or revenue minus VC minus FC, right? Or in other words, this part is variable profit, or in other words, producer surplus. So you're gonna do producer surplus minus fixed cost. But here there's no fixed cost, so yeah. And very, very, very well said. Okay, but I mean, if you want to use it here, just a quick math. This number is 50, right? This number is 30, and this number is 5. This is I haven't done this before yet, but this marginal cost. So this is 35, right? Yeah. So this part is 1. So this part is 450, and this part is 30 times 30 times 30 divided by 2, so also 450. So yeah, if you do find a producer surplus, which is this place, indeed it is 900. But that's another way to do it. But again, revenue minus cost is also possible. And it's never good, it's never wrong or bad to know that variable cost is the integral of marginal cost. Just as much, it is very good to know that producer surplus is variable profit, which means just the exact same thing. Okay. All right, next question. So now is the tougher part, I suppose, though. I mean, if you do know that producer surplus is the way, it's actually not that tough. But to many, it's hard to realize. So here we're saying, okay, what if monopolists can perfectly price discriminate? So let me actually go back to this sheet again, because this is the graph we're going to be using. But now, you see, instead of going to the single price, we use MR equals MC. We could directly use P equals to MC. Okay, or in other words, demand curve equals to MC. So let's draw. Let me draw the same graph. Okay, this is your D. This is your MR. This is your MC. This is 55, 65, 35. And now the question is, what's here? Well, all we need to do is merge them together, right? P equals MC, or demand curve. Now, by the way, sometimes on these questions, if we give you, what P equals MC, you might not know what the P means exactly. What it means, okay, is that it's just where demand curve intersects MC. Well, why? Well, first, remember your demand curve. Like I know in this question, let's say, it initially gives you Q in terms of P. All you need to do is manipulate it, and you get P is equal to 65 minus Q over 2, right? So now you get it in terms of P. And indeed, you see, if your demand curve expressed in terms of P, then it pretty much just means price, right? So yeah, that's why price is equivalent to the demand curve. But from a more theoretical perspective, another way to look at it is that, well, it's whatever demand curve is, it fundamentally is just given the quantity you produce, or given the quantity supplied, the amount which consumers want to pay, right? So, for example, in this case, if you have this shortage, right, this scarcity, instead of being at your price, perfect equilibrium here, you have your quantity here at 30, then customers are going to pay more, 50, instead of like a lower number, which is how it should be in a perfect competitive. So yeah, and also, essentially, right, because the demand curve just shows you price given quantity, when we intersect P equals MC, we find the quantity at their intersection, right? For example, MC and D intersects, the quantity is here, and we use that, we find the price. So yeah, that's a couple of ways of looking at it. So without further ado, let's plug in numbers. So we got the demand curve already, very good. And P is equal to MC. MC is 5 plus Q. Okay. So how are we to continue with that? Well, we switch the places, right? 65 minus 5 is equal to Q over 2 plus Q. So that's 1.5 Q. So 60 equals to 1.5 Q. If you do the division, 60 over 1.5, in other words, 60 times 2 over 3, that's going to be 40 equal to Q. Okay, so now you got Q. And the question is, well, what's P? Oh, you just plug it back in. Now we have Q is 40. P is equal to 65 minus Q over 2, right, which is 40 over 2. So 65 minus 20, so 45. You could also just plug 40 into here, into MC, and you get 5 plus 40 equals to 45. That also gives you a price. Both ways possible. So we got this. But now the question is, now the question is, if it can perfectly price discriminate, how much profit they will make. Okay. So this is going to be a bit annoying, isn't it? Because it seems it seems hard. And now the reason fundamentally why it's hard, okay, let me say this, is because in a first degree or perfectly competitive, but perfectly price discriminating monopoly, you charge each customer different. It's not single price where you charge all the same price. Here it's different, varying by customers and their individual traits. So a person poor might be here, a person rich, Jeff Bezos, might be there. Okay, so it really depends, and therefore you can't even use a set price. So how are we to do this? And we talked about it before, right? We're just using producer surplus, and that is the way indeed. But what exactly is the producer surplus? Okay, what exactly is the producer surplus? So let's see, on this graph, right? So you see, for the producer surplus typically is going to be this much, right? But here, you get more than that. You get also the entirety of consumer surplus. And that's what makes it a perfectly price discriminating firm. Okay? You suck up all the consumer surplus that consumers previously had in a perfectly competitive market. So, it's sort of ironic. They both have the name perfectly. And I mean, they are perfect because they don't have any deadly loss. But normally in a perfect competitive market, the upside is to consumer, the downside is to producer. It seems pretty fair. But here, producer takes it all. Okay? So now we just need to find the producer surplus, which is this triangle. PS is equal to 65 minus 5 times, what's our quantity? 40, right? 40 is going to be, and there's a triangle, is a time 1/2. So 60 times 40 times 1/2, that's going to be 12. Now, later, I was thinking about this question. I was also seeing how we might be able to do it without using this. And I mean, this might be a bit tangential. I'll just use 2 minutes to explain it. I'm not sure if it even is correct, to be honest. So maybe it's wrong. In that case, just don't listen. Okay. But so I use reverse engineering. We know that this part is going to be your cost. Okay, so because it is your variable cost, and then said that your fixed cost is 0. This part is a variable cost. The area of this is 5. This all the way up to is 45. So that's So hold on. This is from the 5 to 0. This is 40. This part is 40. So that part is 800, and that part is 200. So we know that the variable cost is actually equal to 1,000. It's just this part. So that means that the total amount by which you earn must be equal to this part. Okay? And so that's your total revenue is going to equal to this trapezoid shape. I don't know if you can see it, but I tried to trace it. And that's fine. But the question is, if we use this part minus this part, we get our producer surplus, which is our answer of 1,200. And the reason why we have this part being the entire this part being the entire revenue is because from here to here, if you're rich, they're free to charge you however much you want. If Jeff Bezos, they're pretty much going to charge the whole 65. If you're who's poor, if you're homeless beggar, then they're going to charge you something near 45. Okay, but it's not going to go lower than 45 because if you go lower than 45, you'll be breaking the equilibrium. So it's just going to be between prices of here and here that you charge and quantity given them. Okay. So that's why this is your whole revenue. But then it also occurred to me that one of the ways to find this might be just to use the midpoint. Okay, so just to use the midpoint, which is here, between 65 and 45. So that would be 55. And if you do 55 times, so 55 times 40, and you don't need to use the 1/2 here because you're finding a This is not a triangle, this is a trapezoid, right? And the reason why we're using 45, you can also say it's because we find the average of this length to that length, okay? And the average of that is going to be the midpoint between them, which is 55. Minus your variable cost, which is 1,000. And that's also going to give you 1,200, but it's a much more complicated method. It is correct, I believe, but it's just not the best way. So you see, it's good to know that producer surplus is equal to variable profit, which is going to be your final profit if there is no fixed cost. But even if there is a fixed cost, all you need to do is PS minus fixed cost, and you get your final economic profit. Okay, so that's 2021. And last question of this part, 22 is asking how much they'd be willing to pay to allow for this perfect price discrimination. And well, this is just a difference between the profit here with a perfect, first degree price discrimination minus profit in a single price discrimination. And that's going to be 1,200 minus 900, so 300. Okay, now to explain this, it really isn't that complicated, although the question might sound weird. So the thing is this, okay, for most monopolies, they aren't that capable. They don't have the capacity to price discriminate everybody because they don't have access to everybody's information. At least it would be illegal if they know that your annual income is like 80,000, or if your annual income is so and so, and they charge a different price than that. However, here we're saying if they can pay for this information, they pay for annual income, they pay for your social standing, they pay for this trait, that would give them the choice to charge it differently for you. Then that is going to be the key to how they can perfectly price discriminate, right? So without this information, they can't. They have to use the basic one of a single price. So there's actually not necessarily discrimination there to individuals. It's just a single price to everyone. But here, with access to this information, they can then discriminate everybody. And the amount of most that they're willing to pay is just a difference between the profit of having this thing and the profit of not having this thing. Right? If they want this thing, well, yeah, but if it's more than $300, then not necessary. I'd be better off just doing a single price and not paying for this extra information. So that's 22, and the answer is 300. Okay, and the last part, which also isn't very easy, is about a single price, right? Except it's called a single rental rate, so it's the same thing, right? And then I say single, we just know it's single price, okay? Regardless of whatever is the attribute after that, rental or whatever. And after that, we're also going to find a two-part tariff. Okay, now here's a heads up first. Two-part tariff is fundamentally very similar to this perfect price discrimination, right? And why is it similar? Well, first, they both use P equals MC. Second, they both hijack I'm not even sure I used that right, but yeah, they both just take over, the consumer's surplus, okay? And in a perfectly competitive market, perfectly price discrimination monopoly, they take it once and for all. But here in a two-part tariff, they take it and very insidiously, they mark it as the tariff. Okay, so this is they're very, very disgusting. Okay, they charge this as the basis for you to even enter the market. They make it sound like you're earning a good deal, but in fact, at the start, you're paying your consumer surplus already, and you need to pay it to even enter. But we'll apply that into practice later. For the moment, just know that they're very similar. So first, let's do 23-24. So Merrill Corporation, they have a demand curve again. Thanks to the professor, it is a P equal to something cubed. So 45 minus 0.025, right? Now that's good, okay? But again, this is a single price monopoly, right? So what's the golden formula? MR equals MC. right? So having this is not enough. Sure, it's good news. This is your D. But having this is not enough. You want to find MR. And again, to find MR, you're going to do the derivative of revenue. And to find revenue, you're going to find P times Q, okay? Now, again, if you know the shortcut, you might already realize that demand curve is just going to be 45 minus 0.05 Q, okay? But on the test, don't bother with the shortcut. And here I'm also not going to use it. Just because, why, right? You know, you have ample time. So yeah. Okay, so quickly doing it, you have PQ equals to 45Q minus 0.025Q squared. So okay, right, MR is going to equal to 45 minus 0.05Q. Data speculated. This is our MR. Okay, shortcut. And what's our y-intercept? Well, y-intercept is the same for both. It is all 45. And we have an MC. Well, we do have an MC, and very well actually. The MC is horizontal. Okay, that's, you might not have seen it very frequently, but it is what it is. Just say it's for every extra bit, you cost the same. Okay, so there's no such thing as economy or diseconomy of scale, but that's how we would mark it. And so, okay, to find MC is given to you at 30. Okay, and that's good. Now we just need to find, okay, what's the quantity and therefore what's the price we need to charge. All right, so let's go for it.
Can you lower the paper?
Thank you for that. So MR equals to this. MC equals to 30. MR equals MC. So 45 minus 0.05Q equals to 30. So okay, 15 equals to 0.05Q. That's 20. So yeah, 20 times 15. So Q is 300. Okay, here we have Q. And the question is, given a Q of 300, what's our price? Well, what formula could we use to find this? Well, we just need to see what line it's on and we know what's the right formula. Because you see, this point that we're trying to find a price is clearly not MC or MR line. So we're going to use demand line. Okay, demand line has this, right? Vertical, yeah, here. So 45 minus 0.025, 300. Okay, that's just 45 minus, this is 300 times 1 over 40, right? So yeah, 45 minus 7.5, so that's 37.5. Okay, so that is your optimal rate per hour for a single price. All right, and what about question 24? Well, they're asking profit. Well, okay, how are you to get profit? Well, I mean, a couple of ways. If you know what producer surplus is in this case, then sure, you can just go for it. But the other way, you know, is to just stick with revenue minus the integral of marginal cost or variable cost. I'm going to do that here because honestly, looking at this graph, what is the producer surplus exactly? I can't guarantee you it because you see, this is not your most conventional graph, right? Normally you have MC as being like a straight up line and your PS would include this part, but here it doesn't. So theoretically, you know, it probably would be like this part, but I can't guarantee you that. So instead, let's just go with the formula. All right, and after that, maybe we can find what the MC would be. Sorry, the PS would be. So, but before we go that, let's realize that in this question, fixed cost is 0. So another generosity from the professor. Okay, so profit is equal to P times Q minus VC. Okay, VC is what's there? Oh yeah, VC is just marginal cost is 30, right? So the derivative of that, the integral of MC, is just going to be 30. So now we have what's P again? P is 37.5 times 300 minus 30, 300. So if we know distributive property, we could just format it in a way like 37.5 minus 30 times 300. By the way, this is P minus ATC times Q. Okay. Although, yeah, there's no fixed cost. Yeah, this is. So that's 7.5 times 300, giving you 2250. Not bad. And if we go back to here, well, this part, 37.5. Well, first, this part is, yeah, so you see, this part, our producer surplus is only this box. Only this box. The part above would actually still be consumer surplus. So, I mean, unless if you're very certain that this must be your producer surplus, then I don't really recommend you to go into it. Doing something like this is safer, and it also helps you to realize, oh yeah, this is a producer surplus, and the part at the top is a consumer surplus. It also makes sense because in a single price monopoly, consumer surplus still exists. It's not as extreme as the two-part tariff or a perfect price discrimination. And likewise, the part under here would not be producer surplus because it is actually it is parts of your variable cost. Okay, that's variable cost that has already been included in here. Okay. Now, here's question 23, 24. And now the question is, well, what happens if they implement a two-part tariff? Okay. So in this case, if they implement a two-part tariff, they would actually have this, right? So in a two-part tariff, instead of using instead of using MR equals to MC, we use P equals MC. And well, we already know that MC is equal to 30, so P is also equal to 30. Yeah, 45, 30. And the profit in the case of the implemented is going to be this entire thing. This entire thing. Yes. How much is that? Well, it's going to be 300, right? So this is 30. 45 minus 30 times 300 times, actually, no, hold on. No, hold on. Right. So in this case, you see, oh yeah, coming back to this graph, this is not the same quantity anymore. It's not the same quantity. There is 300, so we can't use it like this. So let's go back. We know that price is, 30. That's good, but we don't know what's quantity yet. And how do we get quantity? Well, you could choose to either use MR or the demand curve. And it's gonna not be MR because remember here, this is not about a single price anymore. We use MR equal MC. Here we use P equal MC, which in other words, just D equals to MC. So we plug it into our demand curve, which is P equals to 45 minus 0.025, Q being unknown. But we know P is 30, right? So 45, so 30. So 15 equals to 0.025 this, and you'll get, by doing the equation, that you'll get that this is going to be 600. So now you get the quantity of 600. Okay. So, if we are now to do the total profit, or in other words, the total consumer surplus, then, all right, what is it going to be? Well, you see, it's going to be, let's see, 15 times 600 times 1/2, right? That's your profit. That's just going to give you 9,000 over 2, so 4,500. There you go, right? That is your profit in a two-part tariff. 4,500. The entirety of this triangle will produce your surplus. But in a two-part tariff, instead of making it, this graph, by the way, would also apply for like perfect price discrimination, first degree. But instead of making it, depending on the individual traits of the consumer, here you are actually so-called benefiting them by giving them a decent equilibrium price of 30, or it's just a perfect equilibrium price. Right? You're going to keep it at 30. But you're also going to charge a tariff, or what it's called an optimal access charge. And that is going to be this thing, right, that you need to calculate. And for this question, there are a couple of ways of doing it, but I suggest to just stick to, let me see. So it's sort of difficult, to be honest. The formula normally for the two-part tariff or not the entry fee, which I would call it tariff, is the consumer surplus. But in this case, you might be wondering, well, what exactly is the consumer surplus? And that's sort of a question, because if we're doing this entire part, that includes our producer surplus, right? So we can technically compare it back to here, and you'll realize that our producer surplus is technically this triangle. That part represents our original surplus, and these parts would represent our original consumer surplus. Right? Or another way, correct me if I'm wrong, Letitia, to find the two-part tariff, is it possible for me to subtract basically this triangle here from our original producer surplus? Or not really? So the definition of the tariff is just your consumer surplus. But you see here, it's not necessarily easy to calculate. And well, the answer, long story short, is going to be 2250. So it's just going to be exactly your, so it's just going to be the combination of the consumer surplus here and here, okay? And this part being your original producer surplus. So yeah, the tariff is 2250 and the price is 30. But this is very well known because the price is just your equilibrium price. But the tariff, let me see if there's a better way to explain it online than me. Yeah, so okay, how about let's stick to, well, you see, the issue of a question like this is that it's not your standard way of a two-part tariff, because your marginal cost looks like this, okay? So that is actually the last thing I want to explain today, though. If there's any questions, I very much appreciate if you ask, I'll explain it here as well, because I'm sure many of the students watching this video will have it as well. But you see, typically, you have a marginal cost where it looks like this, and a MR or demand that looks like this. And in the two-part tariff, we don't care about the marginal revenue, just like in a perfect price agreement. We don't care about it. But we have this, right? And this is your CS, this is your PS. This part is the entry fee. This part is the entry fee. Okay? And that's very straightforward because that is your previously your consumer surplus. But here, if we are to have an MC that looks like this, well, let's see. So first, this is, no, you don't even have this line. You have an MR, yes. You have an M, again, MR doesn't matter, but you have an MD that does D. And so, question is, what would your producer surplus be originally? This entire thing is 4,500. So originally, your producer surplus, if you're pricing it here and you're charging, then I suppose, like, if you're pricing this thing here, right, then shouldn't your producer surplus be 0, right? So, I mean, this is going to be hard. So this is very typical, and I hope that's sort of the question she asked in the exams. But this is sort of an issue, at least it's an issue for me. So, okay, the ECON page, this random website, gave me something that looks like this. Share. It gave me something like this. So, I mean, I suppose this part entirely would be your consumer surplus. It doesn't mean that we found the profit wrong, because remember, this is 45, right? This is 30, and this is 600, and by any logic, this whole thing with 4,500, and that makes sense because that is indeed your total profit. But your individual consumer surplus, well, that's the pain in it. But I mean, maybe like this, that's your consumer surplus. I don't know. Okay, it's hard to say. It's hard to say. But for questions like this, my way, if it comes up first, it's always good to ask Professor Kaplan because she knows about this better than me. But I say it might just be your total surplus with or your total surplus or your like a total profit, right? I.e. Profits. Producer surplus. With a two-part tariff minus your original producer surplus in a and I feel like that might give you the CS. That is also your entry. So my mistake, I should have prepared better for this, but we did manage to run through all of it. So I think that is good. Last thing I sort of want to share with you guys is how the graph might look like if it's in a second or third degree. And I mean, I don't even need to draw it because Google has better drawings than me. But let's just say second degree price discrimination. And it's a fairly interesting graph. It also sort of shares it with a third degree. So it will look something like this. I know you guys can't see it. Let's see if I can mod first. But no. Exit to main. And projector has PC. Yeah, okay. So you see it's going to look something along the lines of this, where you have different boxes according to different quantities you buy. Yeah, and it's also going to be pretty similar in third degree, except third degree is about consumer traits, right? Like whether if they're adults or children or something like that. And in that case, well, it's sort of hard to visualize that, but it would also look something like this. And yeah, okay, so that's all. Any questions from you guys? Yes.
I just submitted and it still says question 5 is wrong for 2,500.
Jesus Christ.
Said you just didn't give credit there.
Oh,
Which is strange because I marked this 2,500 yesterday night. Did I not save it? I mean, it says 2,500. Maybe you use like an older version of the grid such that it's had like the older answer key, but that's a very bad excuse. So yeah, the professor today, I mean, I think she sent a message. Yeah, so it is 2,500, and yeah, everybody gets credit. So that's that. Okay. Anything else? Yeah.
Can you go like over 26?
Oh, that's the hard one. I'm not even
Okay.
sure about it, but yeah,
Okay.
what about it? What is it? Let me see where it's going. Yeah. So the tariff is 22.50, price is 30.
That's wrong.
It's not right?
Yeah.
Then, did I? Okay, but that would be quite a shame. But I do have access to the answer key, so maybe. Oh, I feel like oh, shoot, right, all right. So, okay, it's actually 4,500 being the entry fee. And it's not even hard. It's just that my brain messed up, and I can explain it to you guys here how I did. Okay? It's probably 4,500, but let me double check the answer key just so that you guys can get it.
it is 4,500.
Yeah. Okay, so how did my brain mess up there? Well, you see, I was thinking of just using this triangle, right?
Zoom share your
Yes,
paper.
thank you. Camera controls. No. How does it? Oh, right. I need to stop sharing. Yeah. So just using this triangle, let's say it's 30, 45. Before the establishment of this two-part tariff, in other words, when it was in a perfect competitive market, this entire thing is actually a CS. So now you transfer it so that this would also be your tariff or entry fees. Okay, so yeah, originally this entire thing was a CS, and let me explain why. Because if you price your price at 30, right, and that also is the price of your variable cost, but that means that the part here, which is originally supposed to be a producer surplus, is actually 0. We have 0 producer surplus. For every good you're producing, you're selling it at the exact same cost. You're not earning any money. You don't have any surplus or therefore any variable profit. But here, oh my God. So here, CS is this, right? Before before we charge the two-part tariff. But after we charge the two-part tariff, the two-part tariff, the monopolist hijacks all of your CS. Originally, they had no PS, right? So this part is 0, but they get all of this, and they actually get all of it through acquiring all of your consumer surplus. So this is the part, this 4,500 is going to be not only your producer surplus, or in other words, variable profits, it's also your tariff or entry fee. And if it's not because of this tariff or entry fee, you won't earn any profit, because again, you see in the two-part tariff, you're still pricing it at 30, and the quantity being 600, you're going here, you're not earning any profit, not at all. Okay? Pricing at 30 and producing at 30, your profit is 0 for every good produced. But because you can acquire this box here, so you do get producer surplus, because you're forcing consumers to pay the tariff before even entering the market. And by doing that, you get all of their consumer surplus, and you succeeded as producer surplus. So the part that I messed up is that I did not realize that, oh, originally actually our CS is the entire thing. And thereby, in my brain, I saw it was like half of it. So I saw 2250. And that just forced me into this trajectory of, into this downward spiral of, trying to find your PS, which by the way, this is completely wrong. Okay? But here, you see, technically, your PS is non-existent if this is a PCM. Okay, your PS is non-existent. This whole thing is a CS. However, if it's a two-part tariff, if it's a two-part tariff, or a first degree, in other words, perfect price discrimination, then this part is succeeded as your PS. Okay, anything else?
So what was the answer to 11 again?
Let me see. Why can I not minimize this movie? Oh, you know what? F it. Another thing I shouldn't say. I would just share the screen. 11, right? Which is the 0.15 question, right? Yeah. Decrease output, because you see, back to that in an elastic line, you can increase price a lot and only sacrifice quantity by a bit. That's going to raise your total revenue up. You're going to earn more by decreasing profit, increasing price. Anything else? If not, I'll sign off now. Hope you guys enjoy watching the video. It's not entirely boring, but yeah. And guys, if you have any questions that's like now, just feel free to ask. Okay, so end meeting.